Everyone, myself R. Kalai Vani, MCI MPhil, Assistant Professor, Department of Computer Science. Now I am going to take the subject name Compiler Design for PG students. Okay, in this Compiler Design, in this topic, now we are going to cover these three topics. First one, introduction. Second one, how the compiler design as a working process. Third one, phases of compiler. We are going to discuss about these three topics. Okay, first one, introduction. In introduction, just we want to know about what is compiler. Okay, compiler is a large program. Okay, then it can be read as a one programming language. This one programming language is called as source language. Then it can be translated into the another equivalent language. The another equivalent language is called as a target language. This source program, compiler, target program. If we give us a source program is a high level programming language. We give high level programming language, the compiler translate it into the machine level language. Then it can produce as the output. The compiler process is used to translate a source program into target program. Another important role is the error message. It also detect the error which place it can be occur. Okay. Then compiler, these are the two functions. First one, compiler translate a high level language into machine language. Another one to detect the error. Okay, this one is the introduction of compiler. Next one, working process. What is the working process of the compiler? Source program, then compiler, object program, executing computer, result. Source program is a high level programming language. Then it takes as a machine level language, converted into machine level language. In the object program, it is a machine level language. Then executing computer, we give as a data. Then it take as a data and produce the result. In this process, it produce any error. In the runtime compilation, if any error occurs, it display the message. This is the process of compiler. Third one, phases. First one, introduction. Second one, working process. Third one, phases. What is phase? Compiler operates as a phases. It contains several phases. A phase is a logically interrelated operations. The compilation is divided into sub-process. Compilation process always running into the sub-process. This sub-process is called as a phases. There are the several phases in a compilers. Okay, first one, lexical analyze, syntax analyzer, semantic analyzer, intermediate code generation, code optimization, code generation. If we give us this one is a source program. If we give us a program, these all phases occur, then we produce as the result as a target program. Then it contains as a simple table. Then if the errors any occur, it display as the error message. Then we are going to take as a one by one phases. First one, lexical analyzer. Lexical analyzer is also we called as a scanner. In the lexical analyzer, it scans the source program. It reads a stream of character. It reads one by one character. Okay, wow. This one by one character is a source program. Then it can be grouped into the character. This grouped character is called as a tokens. Okay, for example, which one is your token? New value assign old value plus 12. In this new value and old value is an identifier. Then this one is an assignment operator. Then this one is an add operator. Then 12 is an numerical value. In this phase, it can be separate as an character by character. This group of character is called as an tokens. In this, these are the tokens: assignment operator, add operator, numerical value. This one is the first phase. Second phase, syntax analyzer. The output of the lexical analyzer is the input of a syntax analyzer. The syntax analyzer, it look like as a tree-like structure. In this tree-like structure, it contains as a child node and the interior node. Interior node refers as an operation and the child node refers as an argument value. Okay, for example, new value equal to old value plus 12. If we apply this as syntax analyzer, this one is a assignment operator. New value equal to old value plus 12. In this example, we take how to divide as a tree-like structure. This is an assignment operator. The assignment operator is equivalent. Next one, new value is an identifier. Then expression in this, it contains as an expression because old value plus numbers. So expression plus operator we use as expression. In this expression it can be divided, it can be converted into the identifier, then old value, then this one is an expression, this expression is a number is a 2. So syntax analyzer, it can converted into the tree-like structure. In this phases, third one is a semantic analyze. In this semantic analyze, the important part is it is used to type checking. Type checking means if you want to check means each operator has each operand. In this, each operator has each operand. In this process, semantic analyze main important part is as a type checking. For example, new value equal to old value plus 12. Okay, then sum equal to a plus b. Sum equal to if we assign as a double, a equal to int, b equal to character. In this it has no syntax error, but it is as a semantic error because it has a type mismatch. Next phases is intermediate code generation. In this intermediate code generation, it contains as a two important properties. First one is easy to produce, second one easy to translate. Okay, then intermediate code generation, it contains as an intermediate form. In this intermediate form, it contains as a 3 address code. 3 address code means 3 operand plus instructions. Okay, for example, new value equal to old value plus factorial fact star 1. Then if we assign as an intermediate code generation, we use as an 3 address code. Already we know 3 address code contains as a 3 operand plus instructions. Okay, then ID1, new value as ID1, old value ID2 plus ID3 star 1. These are the plus assignment as an instructions. These are as an operand. Then we assign as an temp1 equal to integer to real. This is an 1. Next temp2 equal to ID star temp1 because ID means this one, ID3 star temp means in this we assign as a temp1 real value. Okay, next one temp3 equal to ID2 plus temp2. In this ID2 as an ID2, temp2 we assign as an ID3 star temp1. Next we ID1 equal to temp3. Okay, this value is assigned as an temp3. This process is used to easy to translate. Next phase is code optimization. In this code optimization, it contains as how to improve the performance, how to reduce the more steps. Then this is a better steps means faster. First one is a faster, second one is a short code. It is used to the way of procedure to limited. Third one is a target code is a less power. For it also we can in these phases we also use as an efficient algorithm. Efficient means reduce the steps. For example, temp1 equal to ID3 star 1. Temp1 equal to ID3 star 1. These two assign as an temp1. Next one ID1 equal to ID2 plus temp1. It contains as a reduce steps. Okay, this phase is a main important role is reduce steps. Next phases code generation. In this code generation, it takes as an input in a intermediate representation in a source program. In this we assign as a register. In this register it contains as a value. For example, ID1 equal to ID2 plus ID3 star 1. In this register we use as a move R1 comma ID3. This means in the value of the ID3 is moved to R1 register. Next one, multiple R1 comma 1, R1 comma star 1, R1 star 1. These are the multiple. The value is assigned or stored in R1. Next, move R2 comma ID2. The value of identifier 2 is assigned, move to R2. Next, add R2 comma R1. In this process, it contains add R1 register plus R2 register. Then move register use as an R2 comma ID1. In this whole R2 is assigned to as an ID1. This we use as an register. Okay. Now we are completed as the phases of compiler. Okay. Just we want to discuss about one example. For example, position equal to initial plus value star rate. This one is a one sample program. In this step, how to dedicate a step by step phases. First phase is lexical analyzer. In this, we already know about lexical analyzer represent as an tokens. In this, position equal to ID1, ID2 plus ID3 star ID4. Okay, well, these are the tokens. Now we called as tokens. The lexical analyzer, the output of the lexical analyzer is input of the syntax analyzer. In this syntax analyzer, already we know about as a tree-like structure. ID1 assignment plus operator, then ID2 star, ID3. This one is a ID4. These are the syntax analyze. Then next phase in the syntax analyzer output is going to the semantic analyze. In the semantic analyze, assignment operator ID1 star ID2, it reduces the steps and real value. In the semantic analyze, it is used to steps reduce. Next one, the next process it's going to intermediate code generation. In this intermediate code generation, this value are assigned as a temp1. Then ID1 star temp1 is equal to temp2, then ID2 plus temp2 is equal to assigned to temp3, then ID1 equal to temp3. Okay, next step go to code optimization. In this code optimization, it is used to reduce the steps and coding. Temp1 equal to ID3 star 60. ID3 star 60 is assigned or stored to temp1. Next step ID1 equal to ID2 plus temp1. In this temp1 it contains as the ID3 star 60. Next phase is going to code generation. In this code generation, we use as a register. Move ID3 comma R2. In this R2 register is moved to the ID3. Then R2 comma 60. Then value is multiplied. Next R2 comma move R2 comma ID2. The value of R2 is moved or assigned or saved to ID2. Next add R2 comma R1. The value of register R1 and R2 is added and stored in the R2 register. Next move F equal to R2 comma ID1. The ID1 value is stored into the register R1. These are the sample example of phases of compiler. Okay, thank you all.